All right, hello everyone. Here are some notes for 1.2. We're going to look at symmetry and intercepts. Okay. I feel like a lot of this stuff you might know, and it's review, but it will be on the quiz, so I wanted to go over it. If at any time it's confusing, you can obviously rewind it or pause it to look at these notes, or shoot me an email as well. Okay. All right, so here we go. Just a quick definition of x-intercepts and y-intercepts. All right, you guys know what these are. Okay, x-intercept is where the graph crosses the x-axis, which I labeled as red dots for you. Right, we set y equal to 0 and solve for x. Y-intercepts are on the y-axis, right, and you set x equals 0, x equal to 0 and solve for y. Okay. Here's a quick example here, right? In this graph, there are 3 x-intercepts, okay? And there's 1 y-intercept, right? And again, just to emphasize and reiterate, for x-intercepts, see the y's are 0. And for y-intercept, the x is equal to 0, okay? And we know how to solve for these, right? If you're solving for the x-intercept, right, we set the equation equal to 0, and really what we're doing is we're setting y equal to 0, right? In this problem, we factor to x plus 8 and x minus 1, and we solve, right? So there are 2 solutions, meaning there are 2 x-intercepts at -8 and +1. And for the y-intercept, that means x is equal to 0, so we substitute in 0 in for x, and then we evaluate from there, right? It turns out y is equal to -8, so the y-intercept is at 0, -8. Same thing with this problem, right? For the x-intercept, we set y equal to 0, and you get x equals 4, so it's at 4, 0. For the y-intercept, you set x equal to 0, right? And here you get y squared is equal to the square root of -4. You can't do it, okay? There are no solutions for the y-intercept, which means it does not cross the y-axis, okay? And so here in number 3, we ask you to graph it, all right? Now notice when we graph it into the calculator, it's always y equals, right? And so you got to solve for y, okay? And so you got to take the square root, right? And so if we take the square root of both sides, okay, that's what we did over here. But here's where a lot of students make the mistake. They always forget about this plus minus, right? And so a lot of students will only get this part. They say, oh, it's the square root of x minus 4, okay? And here's what they end up graphing. So put in a little coordinate grid for you. At 4, right, if this is 4, they'll graph this, right? It's supposed to be more of a curve, okay? But that's incorrect, right? Because it's plus or minus, so there's also a negative, right? Okay, so that's how you get the other half. That's why this picture is correct, this graph right here. Okay, and so yeah. Okay, one thing I want to remind you of, this is not a function. Okay, remember it does not pass because it does not pass the vertical line test, right? Remember the vertical line test means if you take a vertical line and you sweep it left and right, because it crosses this parabola, crosses this vertical line twice, that can't happen, all right? And so therefore it's not a function, all right? But anyways, just wanted to emphasize again, this is a full parabola because of the plus or minus, all right? Talking about symmetry, okay? If you want to pause it here and read through this, that's fine. Symmetry means graphically we can examine it by looking at the points on the graph. algebraically we can solve, all right, by replacing variables with their opposites. And this you might forget, and so we're going to go over some examples here. Okay. Symmetry with respect to the x-axis means that the x-axis is the mirror line, right? You can, if a curve looks like this, then the reflection is up here, right? Please take note when it's reflecting over the x-axis, if you have a point x comma y, then the reflection point is at x comma negative y, right? So that makes sense, right? The x value doesn't change. Like this is at 2 comma 3, and if you flip it over, the x value is the same, but the y value is now in the negative, so that's why it's negative 3. Okay. Well, how do we do that algebraically? All right, because you have to be able to know how to do that as well, right? And so algebraically, how do we test it? We replace y with negative y, okay? Replace y with negative y, and if the equation remains the same as the original, then there is x-axis symmetry, right? So here's what we mean. Look at this example, right? If we, when we plug in negative y, right, this is the original equation. When we plug in negative y, and when you square it, that's still positive y squared, right? So this equation we ended up with after we plug in negative y is the same as the original, and there's no change, right? So therefore that means that it is symmetric with respect to the x-axis, all right? It's not a function because it doesn't pass the vertical line test, but it is still symmetrical, okay? So then with respect to the x-axis, so some differences here that you have to know, right? If you're given a point x comma y, then negative x, y is also on the graph, right? And so the y values are the same, the 3 and 3, but now the 2 flips over, and that's why it's negative 2. Okay. Algebraically, how do we test it? Now it's the x's turn, right? We replace x with negative x. And then same idea. If it's the same exact equation, then it is symmetric with respect to the y-axis, all right? And so here, right, if we plug in negative x, right, and it's even exponents, so we're going to get the same, x to the 4th minus 3x squared, okay? And so this example, it does have symmetry with respect to the y-axis, okay? And the last one we're going to look at is with respect to the origin, right? And with respect to the origin, if you remember from geometry, if you guys went over it, I know some of you may have not, it actually turns 180 degrees, okay? And so the rule here is if you have a point xy, okay, then if it's symmetric with respect to the origin, then it's negative x, negative y, okay? All right. And so here, 2, 3 again, it's in quadrant 1, and negative x, negative y, think of it, if it's 180 degrees, it's going to flip over, here's the origin, 0, 0, right? It's going to flip to the other side, right, at negative 2, negative 3, okay? And this time we replace both x and y with negative x and negative y. And again, same idea. If the if the resulting equation is the same as the original equation, then there is symmetry, right? So here we have x equals y cubed. When you plug in negative, right, x becomes negative x, y becomes negative y. Since this is an odd exponent, you end up with a negative y cubed, right? And here this is negative x. And if we divide by negative 1, right, we get the same, right? And so therefore there is symmetry with respect to the origin. So here in this slide, I know there's a lot going on, okay? So let me explain. So how did we get all this, right? Well, in order to put it into the calculator, we solved for y, right? And so let me just quickly go through. We kept it as a fraction, and we simply subtract this first left fraction over to the other side, right? Then we've got negative y squared over 16 is equal to negative, and then x squared over 9 minus 1, right? And then we multiplied everything. We multiplied both sides by negative 16, right? So times negative 16. All right, so we have y squared is equal to, I think we just kept it. Yeah, it looks like we just kept it. That's going to be 16, and so that means that's going to be, so that's 16, and that's going to be negative x squared over 9 minus 1. I think this is incorrect, right? Regardless, so when we test for symmetry, right, we can still use the original equation. So that's what we did, okay? And so with respect to x-axis, right, remember we changed the y, right? We substitute in a negative y. And so negative y squared still becomes positive y squared. And so we end up with the same thing, okay? So there's no change. It's exactly the same. So therefore, it is, there's x-axis symmetry, right? This one for y-axis, we change the x to a negative x. And since it's an even exponent, this becomes positive x squared. And again, no change. So there is y-axis symmetry, all right? With respect to the origin, all right, we substitute in negative x and negative y. And again, no change for this one. So there is origin symmetry, okay? And so, yeah, I think that's the last example we're going to look at, all right? If you have questions, please let me know. I did upload a review if you wanted to get started on that. You know, we'll go over some of those questions in class on Tuesday and Wednesday.